Hi gang, this is 51 in section 2.4. Now we're looking at continuity. These are both linear cases. So in a linear case, there are no holes, no gaps, no vertical asymptotes. So since these are both linear, each of them alone are continuous. So this is a continuous function, this is a continuous function. The only place we can have a problem is, do they snap together? Because this is a piecewise graph. So the question is, do they snap together or do they gap? Okay, so since this has a positive slope, this has a negative slope. So the question is this one is going up very slowly. So do the two lines snap together, or will the two lines, let's see, this one has the hole, or will the two lines gap? So the only place they can have a problem here is x equals to 2. So at 2, you want to know what the heights are. So for this first function at 2, so half of 2 is 1 plus 1 is 2. So at 2, this one is at a height of 2. At 2, this one is at a height of 1. Okay, so we have a fundamental problem here, because for the function on the left of 2, this point right here is 2, 2, and for the function where x is greater than 2, this point right here is 2, 1. So this graph here does not snap together at x equals to 2. Okay, and remember, for continuity, when you looked over the definition, the point has to exist, the two-sided limits, the one-sided limits have to exist and be equal, and then the two-sided limit has to equal the point. So this would be case number 2, where the limits fail to be equal to each other. The left, so as you approach 2, on this function, on this f of x, it's a DNE, right? The two-sided limit fails to exist. So in terms of continuity, at 2, we have a gap, so therefore it's non-removable. Okay, because if you look at the rules for continuity, the one-sided limits have to exist and be equal, and that's not true in this case. They are not equal. Okay, gang, I hope that helped on this one. I'll catch you. Bye-bye.